estimating atmospheric pressure. Here is a way of estimating atmospheric pressure. What we are using is a luggage scales and a syringe with a plug on the end of it. So if I zero this and try and pull out the syringe, I see it requires a certain amount of force. In fact, if I pull it out and let go, it goes back in. So I'll just make sure there's no air at all in it. Plug it. Now, if I pull it out, say, to the 5 cubic centimetre mark, it requires a certain amount of force. It requires, according to this, 3 kilos or 30 newtons. If I pull it out to the 10 cubic centimetre mark, will it take more or less? Well, we'll see. Pull it out. And it still says 30 newtons or 3 kilos. In fact, if I pull it out to the 20 cubic centimetre mark, it still says 30 newtons. So why is it not changing? Why is it the same regardless of how far I pull it? Well, the reason is very simple. There's nothing pushing it out. The only force that's driving it back is atmospheric pressure, which is not changing. From that value of 30 newtons, or thereabouts, maybe 31, can we estimate atmospheric pressure? Well, we can, of course. Pressure is force per unit area. So what we need to do now is to find out what is the cross-sectional area of the inside of that syringe, because that's the area on which atmospheric pressure is acting. So you could measure its internal diameter and do pi r squared to find the area. But a simpler way is this. The volume of a cylinder is the area of cross-section by the height. But the volume, we know, it's actually written on the syringe. So all we have to do so is measure the length of that 20 cubic centimetre cylinder, and it says about 6.3 centimetres. So 20 cubic centimetres divided by 6.3 is approximately 3 square centimetres. So the cross-sectional area is 3 square centimetres. The force acting on it from the atmosphere is 30 newtons. That's 30 newtons on 3 square centimetres, 10 newtons per square centimetre, or 100,000 newtons per square metre, which is atmospheric pressure. Another way of estimating it is as follows. Here I have a glass plate and a little suction cup. If I put that on here, it takes a considerable amount of force to pull it off. So I can measure that force, and I find it's actually very, very large. But as I pull it, I can see the area behind the syringe, the area of the tiny amount of air just expanding ever so slightly. So the diameter of the sucker gets slightly smaller as it's pulled. And when it's just about to give, if you measure its diameter at that stage and find out the area and find out the force needed to pull it off, you can divide the force by the area and estimate atmospheric pressure that way as well. So pressure is force per unit area.